Good morning, this is Dr. Turner for Integrated Math 2. Today we're going to be covering 6.3, which is starting out looking at different types of triangle similarity. We covered 6.1, dilation, 6.2, we looked at similar polygons. Again, our focus is going to be on triangles. You could apply these same sorts of principles to other shapes, but our focus is on triangles. If we were in person, we'd be doing this a little more formally. We'd be doing two-column proofs or flow proofs to prove that two triangles are in fact similar. Because we're doing this online, it's a little less formal. We just need to show that they are similar by one of the methods that we'll talk about. Just like with triangle congruency from Integrated Math 1, there are all different kinds of ways that we could show two triangles are congruent. Side, angle, side, side, angle, side, 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 hypotenuse, leg, etc. Similarly, we're going to find a few ways that we can show two triangles are similar. Remember, similarity versus congruency is that it's the same shape but different size. Today, for 6.3, we're going to be focusing on angle-angle similarity. Now, angle-angle similarity, you might ask, okay, well, why not angle-angle-angle? Well, if I have two angles that are congruent in two triangles, assuming those are to scale, let's say I had 50 and 60 and 70, for instance. Angles of a triangle always have to add up to 180 degrees. So if I show that two angles are similar, and I'll call this triangle ABC, I'll call this triangle DEF. If I can show that A is congruent to D and B is congruent to E, there'd be no reason to show C and F are congruent because I know the angles have to add up to 180. And if two are the same, I know that the third has to be the same. So it's a little bit redundant to show that third angle is congruent. Just like what we talked about in Integrated Math 1 with triangle congruency. Even though triangles have 6 parts, 3 sides and 3 angles, it's not necessary to show all 6 are the same. Similarly, with similarity, we don't need to show that all sides are proportional or all the angles are the same. So the first way we can show two triangles are similar is showing two angles are congruent. So these are pretty straightforward when we're given all of the measurements. It'll say, are the triangles congruent, yes or no? Justify your response. And you can tell me A is congruent to D, B is congruent to E, therefore they're congruent by angle-angle similarity. So that little squiggle on top of the congruency symbol, we're just writing that by itself. That indicates similarity. So these two triangles are congruent by angle-angle similarity. Unfortunately, not every question is as simple or straightforward as this. We're not always going to be given all the measurements. So for instance, let's say I have two more triangles, and let's say these have a measurement of 30. I'm going to say this is 70, and let's say here I have 30 and 80. Well, those measurements don't match up, right? I have two 30s, but on the top I have a 70 and 80. But remember that your angles have to correspond to the correct vertices. So let's say QRS and TUV. I'm not showing all of my angles here, so it's still possible that these triangles are congruent. So again, angles of a triangle have to add up to 180, so 30 plus 70, that's 100. That means angle S has to be 80 degrees. And here on TUV, 30 plus 80 is 110. Subtract that from 180, that means angle U is 70. So by taking that extra step and figuring out what the missing angle is, I can show that these are similar. And you can pick any two. Angle Q is congruent to angle T, and angle R is congruent to angle U. Therefore, the triangles are similar by angle-angle similarity. So if not all of your angles are showing, it's good practice to just figure out what the missing angle is and then indicate, yes, they are similar, in this case by angle-angle similarity. This section also requires you to do a little bit of review on angle pairs. We spent a lot of time with this on Integrated Math 1. There are a lot of angle pairs in figures that can be congruent. That includes vertical angles, vertical angles, corresponding angles, alternate interior angles, alternate exterior angles, all those different types of angle pairs that we looked at with triangles and with quadrilaterals, those all still are proven to be true. So sometimes you might have a figure within a figure. Let's say I have a triangle like this, and I'm going to draw another line here, and I'll call this HJK, and call these points LM. So let's say I have these two symbols here. Remember when you have the little arrows on two lines, that indicates that they're parallel. When you have parallel lines, that should indicate to you that you have some type of angle pair that is congruent or supplementary depending on what you're trying to prove. So just as a quick review, right, when you have two parallel lines at a transversal, you have all different kinds of angle pairs that are congruent. Vertical angles are congruent. Alternate exterior angles are congruent. Alternate interior angles are congruent. And corresponding angles are congruent. Corresponding angles are when they're basically in the same corner. So the top right angles, the top left angles, the bottom left angles, or the bottom right angles. Those are all corresponding. Those are all congruent. So anytime you see two parallel lines, that should indicate to you that you have some type of angle pair that's going to be congruent. So because these two lines are parallel, these angles here, HJM and LMK, those are corresponding angles, and therefore they are congruent. So if I wanted to show that these two triangles are congruent, then I would need to write that as a statement. Angle HJK is congruent to angle LMK. If you're doing a two-column proof, I would ask, well, how do you know that? And you would tell me, because they're corresponding angles. Also, because these two triangles are overlapping, angle K is shared by both. That's congruent to itself. Again, if we were doing a two-column proof, you would tell me that that is congruent to itself by your reflexive property. But for now, we can just say that that angle is congruent. Those are two angles, therefore the triangles are similar by angle-angle similarity. On a test, if you're asked to show a congruency statement or a similarity statement, you would say triangle, matching up the vertices, HJK is similar to triangle LMK. So you're following the vertices in the same pattern when you write your similarity statement. Let's do one more. So let's say we have, we'll call this A, B, C, D, call that middle point F. Let's say angle A is 20 degrees and D is 20 degrees. Now, there's no indication here of parallel lines. I might assume that AB is parallel to CD, but unless I have those little parallel symbols, I can't assume that they are congruent. However, I do have one angle set that is congruent. A is congruent to D by given information. And even though I don't have any other measurement for either of these triangles, angle AFB is congruent to DFC because they're vertical angles. So I can say angle DFC is congruent to angle AFB. Remember to have your vertex always as the middle letter if you're using three letters to write out your angle. That's two angles, therefore triangles are congruent by angle-angle similarity. In this assignment, it's going to ask you to justify your response. So I don't want to just see angle-angle similarity. I need to know which angles did you use to show that they are congruent by, or sorry, similar by angle-angle similarity. That's all for today. If you guys have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.